Hello, my Algebra 2 students. Sorry I was not able to be there on Friday. What I would like some of you guys to do, hopefully a couple of you guys, is to email me, which is why I put my email address right up here, Kristen_Lascelle@crpusd.org, and tell me, what did you do on Friday? Because apparently I never had a substitute. So were you in the library? Were you in my classroom? Did you get to work on your poster projects? The intent of Friday was for you to actually end up using my iPads to video yourselves presenting. Were you able to do that? Did you get this worksheet? Do you even have any idea what I'm about to go over? Please let me know. I'll give you a couple bonus points if you email me about it this weekend, because it also means that you're watching this video. Okay, so the study guide. I'm going to go over the study guide and go over a couple of problems. So feel free to fast forward if there's stuff you know, watch it again, what have you. So we have our graph on the right-hand side, f of x. So the first thing we're going to name is the domain. Remember that the domain is the x value. So how far to the left and how far to the right does this go? Because of this arrow right here, how far to the left it goes is negative infinity, and you use parentheses because you can never reach infinity, so it's a parentheses, it's not included. And as far right as it goes is the number 4, which is included because that dot is a solid dot. If it wasn't a solid dot, it would have also been parentheses. The range for this one is again negative infinity because it's going down to negative infinity on the y-axis. And the very top of it, which is up there, is a 5, and that is part of the graph, so it's also brackets. Okay, increasing and decreasing. The increasing section of this graph is here and here. So if you're not sure if it's increasing or decreasing, remember that we decide based on starting on the left-hand side and moving our way to the right side, just like how we read a sentence. So if this was our mountain range and I was standing right here, and I started walking to the right, I would start walking uphill. So if I can even get my little guy to move, I would start walking uphill. I can't do it. That's such a pain in the butt. So I'm going to move him over here. I would be walking this way. I'd be going uphill. As soon as I got to the next part, I would end up walking downhill, and then I'd be walking uphill again. So you start on your left-hand side, and you start walking just kind of like how you're taking a hike. So that means that for the increasing intervals, that you are starting at negative infinity. Remember that these intervals are always named by the x coordinate, always the x-axis, the x coordinate. So it goes all the way to the negative infinity. I don't have the actually beginning of my hike. It's all the way to negative infinity, but it ends at negative 4. These intervals for increasing or decreasing are always parentheses because this very, very top part of here, if I was standing up here, I am neither going uphill nor downhill at that exact moment. So it's parentheses. I'm also going to be going uphill between 2 and 4. And again, that's parentheses because you don't count the part where it turns from uphill to downhill. The decreasing is this middle part right here. So when we are going in this part right here, we are decreasing. So we are decreasing from negative 4 to 2. The end behavior. This problem only has one side of end behavior because there's only one side with an arrow, and that is as x goes to negative infinity, y is also going to negative infinity. For problem number 2, the domain. This one's just a line segment. It actually has a beginning and an end, and there's no end point. There's no end behavior, basically. So the domain, x values, it starts at negative 5 and it goes to 1. Those again are braces because those are solid dots. They are included. Same with the range. The lowest, the bottommost y value is negative 4 and the topmost y value is 2. And again, braces, those are solid dots. For the x-intercept, it crosses the x-axis at negative 3, 0, which is right there. The y-intercept is at 0, negative 3, which is right there. Make sure you look at naming the x and y intercepts using context. So if you're going for a hike or what have you, make sure you can also say what they mean. The intervals of increasing or decreasing. There is no increasing. It's not going up in any part of that graph. The decreasing is from -5 to 1. And again, parentheses because you don't count the endpoints. Slope, don't forget Algebra 1. Slope of a triangle, rise over run. You can make a little slope triangle. You could also make a smaller slope triangle. You end up with a slope of -1 over 1 or just -1. Okay, evaluating a function for a given value. So we have t of x equals the square root of 2x plus 5. So if we plug in 2, because that's what it's asking for us to do, so t of 2, we would have the square root of 2 times 2 plus 5. So what I'm doing is I am plugging the x value into my t of x equation. So 2 times 2 is 4, plus 5 is 9, so we have the square root of 9, which is 3. Don't forget, 3 times 3 is 9, so therefore the square root of 9 is 3. Same idea for the t of -2. We have the square root of 2 times -2 plus 5. 2 times -2 is -4. Oh, I wrote the wrong number. I wrote the answer. -4 plus 5 is 1, and the square root of 1 is 1, because 1 times 1 is 1. Now this next one is giving you an answer. I plugged in something and I got an answer of 5. So I started with the square root of 2x plus 5, whatever x happens to be, and I got an answer of 5. There's a couple ways that you can think of this. The square root of what gives you an answer of 5? Well, that's got to be a 25. So this stuff under the square root has got to equal 25. The other way of thinking of that is to undo a square root. You square both sides. Those are the inverses. So we have 2x plus 5 equals 25 because 5 squared is 25. Either way, you get your answer. And if you were to solve that, you get x equals 10. Okay, this is practicing not just putting in a number, but putting in an expression where x is. So we're going to put an entire expression where x is for those equations. So for my f of 2x minus 3, I'm going to put 2x minus 3 where that x is. So I have f of 2x minus 3 is 3 times 2x minus 3 plus 8. I just substituted. This ends up being a distributing problem, which is 6x minus 9 plus 8. So if I were to combine like terms, I would get 6x minus 1. Same idea for my g function. I'm going to put that right there. So I'm going to get g of x plus 1 equals x plus 1 squared plus 3. Okay, x plus 1 squared, do not forget, that means that we are multiplying x plus 1 by x plus 1. It's a binomial times a binomial. You can FOIL, you can super distribute, however it is that you have learned. You can do this little box that I have right here. So if you were to multiply or FOIL in a box and combine like terms, you would get x squared plus 2x plus 1 and the plus 3 that already existed in the problem, which means g of x plus 1 equals x squared plus 2x plus 4, combining like terms. And lastly, again, this is giving you an answer. I plugged in x, whatever it happens to be, and I got an answer of 38. So I use my equation, 3x plus 8, and I somehow got a 38. And if you solve that, x equals 10. I didn't mean for two of those answers to be x equals 10, but they just happened to be. Okay, turn it over. Problem number 5. Again, we're going to be using this graph to answer some questions. This is very much like the assignment I gave you guys that was the function practice tasks. So if we were to look at this graph and I wanted to find g of -1. So if I go over to my graph and I find -1, which is right here, the graph is up here at 4, which means that g of -1 equals 4. Also, for g of 5, if I were to go over to g of 5, which is right here, and go up to the graph, this is at, just kidding, yeah. This is, oh, I just did that wrong. Oh no, I did that right, just kidding. This is at 4. So this one is at 4. Then, if you were asked to find an answer, but you found out the answer was 3, well, what were you looking at? So the answer has to be a 3. So if we wanted our answer to be 3, it's got to be somewhere around here. So that ends up being, nope, one more up. That ends up being here and here. So g of 0 equals 3, because if I go to 0, I go to 3. And g of 4 equals 3 also. Okay, is g of 5 greater than or equal to or less than g of negative 5? Explain your thinking. So if you find your two answers, we can find out that g of 5 is 4, so g of 5 is 4. And we can find out that g of negative 5, which is over here, equals 8. So 8 is a larger number, therefore g of negative 5 is greater than g of 5. If you wrote it the other way around, g of 5 is less than g of negative 5. Okay, the extrema. The extrema are the minimum and maximum, highest and lowest. So the minimum is kind of like the bottom of a valley. The maximum is like the top of a hill. So for this one, the minimum is this bottom right over there. So it is at the coordinates 2, 1. So that is a minimum. Now there is no maximum because of those arrows. That's going to be an end behavior type thing. You'd say what your end behavior is. So you don't have to say, so basically there's no maximum. You don't have to worry about that. Okay, next one. We have this lovely graph here, an arrow on the left-hand side, but a solid dot on the far right. If you find your x and y intercepts, it's where it's crossing the x and y axis. The x intercepts are at negative 6, 0 and 4, 0, which is right here and right there. Just write your coordinates. And the y-intercept is at 0, 2, which is right there. Okay, for the extrema, no. Yes. Oh, I wrote that in the wrong spot. Geez, I'm doing really good today. Okay, the next one. Sorry for all my mistakes, you guys. I'm just learning more. Okay, between negative 1 and 2, if you were to look at the graph, from negative 1 to 2, my graph is going from here to here. So that is increasing. To explain it, remember that you read a sentence the same way you read a graph from left to right. So from left to right, that is going uphill. It is increasing. Okay, for the extrema, the local maxes are the tops of the hills. So if we're looking at the top of the hill, it's going to be those two parts right there. Those local maxes are at negative 4, 6 and 2, 8. Now, the coordinate of 2, 8 is also the absolute max because it is the very tallest that graph ever gets. For the local minimum, those are like the bottom of valleys, so that's kind of like right down there. So that local minimum is at negative 1, 1. However, oh, and forgot another one down here, and at 5, negative 2. However, for the absolute minimum, there is no absolute minimum because of this arrow. So there's no absolute minimum. Okay, for the domain, I'm going to write this two different ways, so it kind of just depends on how you decided to write it. So for the domain is how far left and how far right. So to the left, this goes to negative infinity, and to the right, it goes to 6. 1, 2, 3, 4, 5, 6. This is as far right as it goes. Oh, and that 6 should be included because it is a solid dot. Now, you could write this also in set notation, which is going to be using an inequality. So you could have also written it as a set of x's such that x is less than or equal to 6. So that is another way of writing the domain. Kind of just depends on which one you prefer. I would take both. For the range is how far down and how far up it goes. It goes from negative infinity to as high as 8. That's using the interval. 8 is included, it's that top part. Or if you were to write it with set notation using an inequality, it's a set of y's such that y is less than or equal to 8. Again, I would take either. For the end behavior, there's only one side with an arrow, so you only have one end behavior because you know the other end. It ends right there. So for the side that has the arrow, which is right here, as x goes to negative infinity, y is also going to negative infinity. It's just going down and to the left. Okay, state whether the following relations are functions and explain why. This one is a yes. For every x value, there's only one y value. Don't forget the vertical line test. Same with this one. If I were to take a vertical line, anywhere that I put that vertical line, it goes through it once. This one is also a yes. Every input has exactly one output. This one is a no. If you were to take a vertical line, just say like right here, it crosses that graph twice, right there. Does not work. Same with this one. This one's a no. The input of 1 gives you 2 different answers, and so does the input of 2. So that one is also a no. Okay, I will be at work on Tuesday, so if you have any questions, feel free to stop by, ask me for help, talk to me. And again, if you are watching this video and you want to get a couple of easy bonus points, email me and tell me what happened on Friday, because I want to know what it is that you guys were able to do on Friday. I is in my first name, E is in my last name. Make sure you spell it right or I'm not going to get it. Okay, have a great rest of your weekend, everybody. See you on Wednesday.